Hello and welcome to Coffee Table Physics. I'm Riley.
And I'm Jonathan. The reason you're probably watching us right now is because you wondered, what is dark matter?
Maybe you think it's just like the stuff we're made of, only evil and lurking on the other side of the galaxy, plotting to take over the universe.
I'm going to let you in on a little secret. That's not what it is. To explain what dark matter actually is, we're going to take you all the way back to 1933.
Fritz Zwicky was pointing his telescope at a faraway cluster of galaxies and thought, I wonder what the mass of that galaxy cluster is. Now Fritz had two ways he could go about doing this. The first way involved looking at how fast the galaxies were moving. But how do you do that? Well, a good way of working out how fast a distant object is moving is to look at its Doppler shift.
What's Doppler shift, I hear you ask? Doppler shift is what you hear when an ambulance with its sirens on passes you by. You hear the pitch of the sirens change as the ambulance races past. The pitch, or frequency you hear, is higher than the one that's emitted by the ambulance when it's moving towards you, and is lower when it's moving away. The same thing happens with light. Things that are moving towards us appear bluer as the frequency of light appears higher, and things that are moving away from us look redder. How red or blue the object looks tells you how fast the object is moving.
So, Fritz could work out how fast the galaxies were moving, but how did that tell him how massive the cluster was? Well, something called virial theorem says that the mass of a system is approximately proportional to the average velocity squared of the components of the system. So Fritz put in his velocity values and out popped a mass. But Fritz, like any good physicist, decided to check his answer using the other method.
You may have been taught that light only travels in straight lines. Well, Einstein found out that if an object is big enough, light will curve around it. And when I say big, I mean, the size of a galaxy cluster. This phenomenon is known as gravitational lensing. The more massive the object, the more light is bent. And so Fritz looked at how much light was bent around the cluster and found his two answers didn't match.
So he thought, there's something going on here. I know, maybe there is some extra mass that I just can't see. Matter that doesn't interact with light. I shall call this matter dark matter.
For about 40 years, other physicists said, what a stupid idea. This guy must have been on something when he came up with that. I bet he just did his experiment wrong. I mean, they didn't quite say that, but you get the idea.
Yeah. That was until the 70s, when some researchers found something that made people realise dark matter might actually exist. One group found that if dark matter didn't exist, galaxies would just collapse into a dense clump of mass at their centres. The existence of planet Earth is enough evidence to suggest that this doesn't happen.
A second group thought that it might be interesting to examine the velocities of hydrogen gas clouds orbiting the Andromeda galaxy. Normally, what you'd expect from Newton's laws of gravity is that the further out you go, the slower the clouds would be orbiting. But shockingly, they found that the orbital velocities of the clouds stayed the same as you move further from the galaxy.
At this stage, they had one of two options. Either completely reject a theory that had been embedded in physics for nearly 300 years, or say, do you know what? I think Fritz Zwicky was right. Funnily enough, they went with the latter. And basically, from then on, people have generally thought that dark matter is actually a thing.
The problem is that detecting what this dark matter might be has been quite hard. After the nearly 40 years, physicists are still waiting for a dark matter particle to come speeding into their experiment and announce itself by knocking into an atom.
If and when dark matter is detected, I imagine it will be quite big news. So, hopefully, now you'll not be too alarmed and won't fear that the end is nigh.
Thanks for joining us. If you have any thoughts on the video, feel free to leave them in the comments box.
Plus, tell us if there's something about this wonderful world around us that you think, I want to know what's going on here. We would love to help.
See you here next week.
Same time, same place. Cheerio!